My name is Jay Jenkins. I'm a customer engineer based here in Singapore. In this session, I'm going to talk to you about serverless and what that means for you and your organization, and how you can use serverless on Google Cloud Platform. So let's just go ahead and get started. So first, I just want to talk about Google and Google Search and what happens whenever you type a few words into that search box. People don't often think about it, whether they're searching from the web page or from an application or from their mobile phone. But whenever you initiate that search, a small process spins up just for you and searches across trillions of websites to find you the information that you need and delivers that to your screen. We don't often think about all of the work that goes into that search when you're doing that. We don't think about the servers that are required. We don't think about the network that's required. Another thing is that whenever I check into a hotel and I connect to the Wi-Fi, the first thing I do is I go to google.com. And if I can't reach google.com, my first conclusion isn't that Google's down. My first conclusion is that I'm not connected to the internet. So for me, that's what serverless is. It provides you a service without you necessarily having to think about everything that's behind that to deliver that to you. And it's something that's available all of the time. Whether it's one person or a billion people accessing that, it should be ready and available to you. Another thing I want to think about is electricity. Whenever I plug an appliance into the wall, I expect that appliance to work. Imagine if I were designing a toaster and I had to call the power company and say, look, I'm designing this appliance. It's going to need this sort of power. I need you to give us these sorts of generators in order to generate that electricity for my appliance. You don't have to do that. You just plug it in and it works. And that's what we want for applications. And to me, that's what being serverless means. So serverless. It's a bit of a buzzword at the moment. You can see the growth over the last few months, or a couple of years actually, in people searching for the word serverless and what that means for them. I like to think that that little spike at the end is because we were having this presentation. Of course, I know that's not true. So what is serverless in a Google Cloud Platform context? So let's take a look at compute. When people think about serverless, the first thing they think about is computations. So we have the range of compute options available on Google Cloud Platform. Starting from the left, Compute Engine, where you pick your virtual machine and you install your operating system and your own code and your runtime and your applications on top of that. Then we have Container Engine, which abstracts a lot of that away, right? Instead of a virtualized machine, it's a virtualized kernel. That container has all of your dependent binaries and can run on a heterogeneous infrastructure that you don't have to worry about what the underlying system is doing. Your container just runs. Then we have things like App Engine. So I'll start with App Engine Flex, where again, it's container-based. So you put that in there. Google takes care of the scaling, takes care of the underlying compute, again, abstracting that away. And then Pure App Engine, where you don't even have to care at all what the underlying operating system is, and those containers boot so fast, essentially it can scale to 0. So in that sense, you're really only paying for what you're using. And the last one, Cloud Functions, which I'll go into a bit of detail today. Cloud Functions allows you to have a function as a service. Now let's talk about storage. So people don't normally think about databases whenever they're thinking about serverless. But there's great opportunity to actually move you to sort of a low ops or a no ops style of a database. Again, when people are installing databases, they have to think about the machine. They have to think about the RAM. They have to think about the CPU. They have to think about the I/O on the disk. They have to think about the underlying storage. But if we can abstract some of that away, so again, starting from the left with Cloud SQL, where you still have to understand what the underlying machine is. Cloud storage, where you're only paying for the actual storage that you're using. And again, you don't have to worry about what types of servers or what types of disk those objects are stored on. Cloud data store, where you're only paying for the reads and writes and functions that you're doing on that database and the storage. Cloud Bigtable and Cloud Spanner, which are high volume databases, which provide, again, sort of a low ops infrastructure to make sure that your databases can scale so that you don't have to worry about it and you don't have to understand necessarily how all of that works underneath. And BigQuery. So very low cost storage, a terabyte of queries every month for free, and it can scale to petabytes. No work, you don't have to worry about optimization, building indexes. It will just work for you. And then data pipelines as well. So getting your data in and out. Normally, you would have to think about your ETL. You'd have to think about things like your Hadoop clusters and how you change that data and how you aggregate that data. That can be abstracted away with Cloud Dataproc, but you still have to worry about the machines that those are running on. Cloud Dataflow, which actually takes that and compartmentalizes it further. So you're paying only for what you use. If you're not pushing anything through it, you're not paying for anything. You're only paying for something if you're pushing something through it. Cloud PubSub, which is a messaging platform, which allows you to send messages back and forth between applications. So PubSub standing for publish and subscribe. You're only paying for the amount of data that you're pushing through that messaging queue. So using these different tools, you can actually put together an architecture which is really quite serverless. You can choose the right tools for the right kind of work and not have to worry about that underlying infrastructure. So let's take a look at an example. If I were building an application, so let's say that this application was doing a text analysis and image services, right? So I'm taking in a piece of content from a user, and I'm doing some text analysis and image services on that. I might start with something like Compute Engine, something that I know where I can control everything. So I'm now worrying about my operating system, I'm worrying about the application runtimes, and I'm worrying about my application itself. But what happens if that's successful? Now I have to think about scaling. So I'm thinking about multiple compute engines, multiple virtual machines sitting behind a load balancer. And then what if I'm even more successful? Well, I might have to throttle that a bit, which means I'll have to have the load balancer pointing at virtual machines to help with the APIs, putting it on a messaging queue, and then doing the text analysis and image analysis behind that. So as we grow, that's a lot of work. It's a lot of effort that's actually being put in to understanding how we're going to scale, re-architecting it as we go. And we also, at the same time, have to worry about updating the operating systems on all of that. We have to worry about making sure that our applications have the capability to scale. So scaling your app isn't easy. And a lot of this design would have to be done up front, capacity planning, upgrade planning, scalability design. But a lot of that's wasted time because the cloud gives you an opportunity to actually improve the way that you're designing your applications today. So essentially, you're spending too much time on fixing and fiddling the things that actually aren't important for your application. You're not focusing on the features for your users. You're focusing on the scalability of your application and the operations. Also, those things become difficult to change. This is a tweet by Kelsey Hightower, who's a Googler who works a lot on Kubernetes. And I think this is an extremely important message, that if your ops team isn't flexible or you're putting too much investment in your ops, it makes your organization less agile. You cannot change as fast. And there are new technologies coming out all the time, which means if you are managing all of the underlying infrastructure, that it takes time and effort in order to change that infrastructure to whatever that newer technology is. So let's take another look at that content analyzer. Rather than doing this, rather than going from here, what we really want is just to run our code. Right? We have code that is behind our application. we don't want to worry about the scaling. We don't want to worry about load balancing. We just want to run our code and scale it, whether it's 0 users, where we should pay nothing, or 1 million users. And you can do that with something like Platform as a Service or Google App Engine. What this allows you to do is have that scalability, and it will scale to 0. So if no users are using that, you will get charged nothing. The instances will all shut down. And the first time a user hits that, within milliseconds, a server will spin up in order to serve that user. It will also automatically do the load balancing for you. And it will scale and add more instances for you as well. So with App Engine, you get something that's easy to manage because it's fully managed by Google. You can focus on your apps, and we'll focus on the ops. It's easy to develop because you can focus purely on your app code and the features that you want to deploy. All of that can be built and tested locally. You can do things like traffic splitting, which allows you to do A and B testing, and things like green-blue rolling upgrades as well. And you have your choice of runtimes. So App Engine Standard supports Java, Python, Go, and PHP. And you can have custom containers as well with App Engine Flex. So if you can run it in container, you can run it inside of App Engine Flex. So how does Platform as a Service compare to what we think about as serverless? Well, it checks a few boxes, right? We don't have to manage the servers directly. We don't even really have to think about those servers. It automatically scales as we need. There's no upfront provisioning required. And the app itself is stateless or ephemeral, which is very important, right? Because if you want to be able to scale to 0, that application shouldn't have to hold state. So if we take a look at compute from end to end, starting with Compute Engine. With Compute Engine, we're really looking at supporting things like DevOps, obviously. More importantly, supporting wherever your applications are today. So it makes it easy for you to lift what you have and shift it to the cloud. But there are more opportunities here. You can actually begin to improve those apps. So we have things like Container Engine, which you can slowly move to in your own time, but those services are there for you. And as we move to the right, you can then move to things like App Engine, and then begin to incorporate things like Cloud Functions in your applications. So you can move to low ops or no ops to add additional agility to your organization. And between sort of App Engine and Cloud Functions, we have this serverless zone when it comes to compute, where the scaling happens automatically, and we don't have to think about how those applications need to scale. The operating systems, we don't have to think about patching those servers or upgrading those servers when new versions of the operating systems come out. It does this for us automatically. So again, what is serverless? So when people think about serverless, people think about definitely only compute, right? It's about running code. But as we've also learned, serverless is more of a target sort of architecture for low ops and no ops. So maybe it also should include non-compute. And maybe when you're thinking about serverless, you should think about that as well. Serverless is normally seen as event-based. So essentially, you only want something to happen, or you only want to pay for something whenever an event occurs. If no event is happening, if nothing is happening on those servers, you shouldn't have to pay for anything. And you should only pay for each of those events as well. So you should only pay for what you use. So let's take a look, I guess, at serverless and Google Cloud Platform. And it all started back in 2008 with App Engine, which is Platform as a Service. And as I mentioned before, it also includes things like storage, BigQuery, cloud storage, data store. It includes things like your data pipelines, cloud data flow. It also includes Firebase, which I'm going to talk about in this presentation, Cloud PubSub for message queuing, Cloud Functions, which I'm going to go into in depth in this presentation, but also newer technologies, Cloud Machine Learning Engine, so that you can focus on your training and not have to worry about the scale that's required in order to do that training. And finally, Cloud Spanner, which Winwoo did a presentation on today, which is a global, strongly consistent database. So let's talk about functions as a service. So Cloud Functions provides a serverless environment, which allows you to connect other cloud services with code, but also allows you to create discrete functions. So again, this has serverless features. So you don't have to think about the servers that are running your code with Cloud Functions. It will automatically scale that, whether it's 1 user or 1 million users, and you'll only pay for what you use. If the Cloud Function isn't running, you pay nothing. So there are different types of Cloud Functions. So one are background functions, which are events that we have inside of the platform. And you can trigger those events from Cloud Storage or from Cloud PubSub based on a topic. So an example of this would be I'm storing an image to Cloud Storage, and then I'm automatically generating a thumbnail for that image. Or maybe I'm calling the Cloud Vision API to understand what might be in that image. And then we also have HTTP functions, which allow you to call APIs or be an API. It allows you to use webhooks. And it allows you to call these functions directly from a browser. Some ideas for HTTP functions are things like Google Assistant, a lot of our other Google products, things like Drive, Contacts, but also other things that you might use in order to call those. So Internet of Things is another great example of a great way to implement Cloud Functions. So let's look at some of those use cases. Webhooks, so integration into Slack, for example. API endpoints, so you can create an endpoint for the APIs that you're developing. Lightweight ETL. So as an example, maybe you just want to go and take some reference data from one of your underlying databases and merge that with the data that's coming in from an IoT device, as an example. You can do lightweight ETL, which takes you to IoT. So each of those devices, if they're simply calling a Cloud Function, it makes it easier for them to submit that data. And as I mentioned before, Cloud Events. So let's take a look at what this looks like. So here, I've got the admin console. What I'm going to do is I'm going to create a function. Now, those of you with keen eyes might also notice that there are some Firebase functions here, and I'll talk a little bit about those later. So if I go in to create a function, I'll just leave the default name. I'm going to switch this to an HTTP trigger. You can see that it's telling me what the endpoint is going to be. You'll also notice that it's giving me an HTTPS endpoint, which means that SSL will be automatically included with that endpoint. I'm just going to use the inline editor. And hopefully, I don't forget to close any braces. All right, so I'm going to change this a little bit because I'm going to call this via HTTP through the web browser. All right, I think I've got all my braces, everything. Great, I'm going to choose a bucket. Awesome Demos looks like a good one. And I'll create. So while that's creating, let's talk about what's happening behind the scenes. First of all, there are multiple ways to deploy this. So I showed you the console UI. You can actually choose a staging bucket and deploy zip files. Now this is using Node.js, and we do support NPMs as well. So you can actually package all of that up and deploy those as a Cloud Function. You can also do it directly from the command line, simply by pointing it at a staging bucket and again loading those compressed zip files. And with 3 lines of code, it's also creating an HTTP endpoint, a fully qualified domain, dynamically generating the SSL cert. It's going to give us auto-scaling capability, so as soon as it deploys, it'll be ready to run for millions of users, and I didn't have to worry about infrastructure at all. So you can see that the function has now been created, so let's run this. All right, Cloud OnAir. And since I gave it a query string capability, Hello. Right, so very easy, very simple to create those functions. Inside of the dashboard, I can see what my trigger is, I can see what the source is, and I can even test calling the function from here as well. Okay, so along with that, along with Cloud Functions, you might have noticed that I deleted a line that said console.log. And that's because we actually include logging with that. So any console.log that you do from your Node.js application will be available to you. And it also includes error reporting. So if there are any errors, if for some reason it doesn't return a status of OK, you'll be notified of that as well. And this logging can also be pushed into other tools like Stackdriver. So let's think about sort of X as a service decisions. Right? When do I use function as a service, and when do I use platform as a service? So function as a service is really about scaling at a discrete function. App Engine is about scaling at the app level. Function as a service gives you billing at the per 100 millisecond level. App Engine is per minute billing. Cloud functions are designed to be event triggered, so an event happens and the function runs. App Engine could support events, but you'd have to support those events manually. Cloud Functions currently supports Node.js. App Engine, as I said before, supports multiple languages. And Cloud Functions are really about creating these small, discrete APIs. And while you could do that with App Engine also supports things like websites. While you could build a website under Cloud Functions, I wouldn't recommend using that. And App Engine also does other things for you, like traffic splitting. So you could do things like A/B testing or green-blue rollouts. And it also does versioning. So let's switch gears a little bit and think about back-end as a service. So what is back-end as a service? Back-end as a service creates an entire back-end for your application, including database, authentication, without you having to worry about the underlying servers. We do this with Firebase. Firebase supports Android, iOS, and the web. And it gives you a lot of features. We're going to focus more on the development features, so those back-end services. But it also has other services that can help you grow your application through acquisition and re-engagement. And it also integrates with things like AdMob to help you earn revenue from your applications. So I'm going to focus on a few things. So the real-time database, authentication, and cloud messaging. What is a real-time database? What do we mean by real-time? First of all, the real-time database that comes with Firebase is a NoSQL database. But this NoSQL database has the capability to synchronize and do conflict resolution in real time. And you can access this directly from your application, so that when one field updates, all of the applications, no matter where they are in the world, can be updated in real time as well. But what if I'm offline? It will still work. Essentially, with Firebase, it will store all of these updates locally. And when you're reconnected, it will then synchronize that to the real-time database. It also includes Firebase Cloud Messaging. Doing notifications across devices is hard. iOS, Android, web, how do I do notifications there? Firebase includes the capability to do notifications on iOS, Android, and in Chrome browser using Chrome notifications. This helps to drive user interaction. It helps to notify the user if something's happened inside of the application. And it also includes authentication. And we support authentication from Google, Facebook, Twitter, and even GitHub for sign-in. We also support simple email and password logins, including all of the infrastructure to actually create those accounts. So really this back-end as a service architecture allows you to create your application once, use these back-end services that are on Google Cloud servers to provide real-time authentication, a real-time database, authentication, and messaging, and orchestrates that all between your devices and websites. So when do I use a more complex database? So the Firebase database is a NoSQL database, but it's primarily designed for mobile applications or web applications. But it does have fantastic support for things like real-time data sync. Cloud Data Store, as one example of the types of databases that you could use inside the Google Cloud Platform, is also a NoSQL database that's mainly designed for back-end services or massive scale. In order to do any sort of data synchronization, however, you would have to query the database yourself and do the updates across those devices yourself. So before we talk about whether you should go serverless, let's actually take a look at an application. So here's a friendly chat application. If I take a look at Firebase, I can see that right now, under authentication, I've enabled Google as a sign-in provider, and currently my application has no users. If I take a look at the database, there's nothing in it, right? No structure, no fields. It is an empty database. If I take a look at storage, I've got a bucket here. Those of you who've used Google Cloud Platform before might realize that this is actually a Google Cloud storage bucket behind the scenes. So let's log in. So there you go. I've logged in. If I go to friendly chat and check in authentication, you can see that a user's been added. Let's go back to the application. You can see here that the Firebase bot has actually sent me a message. That's actually done through a cloud function. So if I go here and go look at the cloud functions, I can see that I have a number of functions. So first of all, you can actually see that function that I created. But you can also see other ones as well. So you can see add welcome message. And this is actually listening for the user create event. So anytime a user is created, that welcome message is added. Let's go back. So I'll just say, hello, Cloud OnAir. Now, earlier I was talking about real-time databases. If I go in here and look at the database, you can see a few things. Number one, I have a token for my user. But number two, I have a couple of messages. One, which was written by the Firebase bot, and another from myself. If I change this, you can see that it's updated here. And if I go back to the application, you can see that it's updated there as well. Right, so a real-time database where the messages can be linked and everything can update in real time. So I also support images in this application. So I will upload a picture of a dog. And if I go here, go to my storage, I can see that a bucket has been created. And linked with the message, I can see that it's uploaded that file. Of course, chatting by myself isn't much fun. So let's bring in another user. All right, so I'll sign in here. It's going to ask me for which account. I'll make sure I choose a different account. And again, I can see exactly what the other person's typed and the image that they've uploaded. Let me zoom in a bit for you. And again, since I've signed in for the first time, it's giving me a welcome message. So great, I'll send something back. Send a message of a cat, or a picture of a cat to try to keep the internet balanced. One of the things that I could do, though, for example, is on that Google Cloud Storage bucket, I could have an event listener. So I could, for example, check for whether there is adult content, or I could check whether there is violent content by making a call out to the Cloud Vision API. As you can see, what I've done with that code is I've actually checked to see if it's an image of a cat. Because again, I feel that there are way too many cats on the internet, so we'll blur those out. And that's all done inside of Google Cloud Functions. So again, if I go back to my functions, I can see this blur offensive image request has run. I can go to my storage. I can see that I have 2 separate folders from the 2 separate users inside of 2 separate chats. I look at my database. I can see that I have multiple messages here now. You can see that the one that was moderated, I've actually added another field on the fly saying that, in fact, this message has been moderated. So should you go serverless? So obviously, if you have existing monolithic applications, it's difficult to do, and that's why Google Cloud Platform gives you a choice. You have the choice of using infrastructure as a service in order to support those monolithic applications, but also the capability to use newer features, which can move you towards lower ops. If you're using long-running compute tasks, this really isn't designed for something like Cloud Functions. You really want to have if you really want to have a longer running task, you could use things like App Engine. But again, depending on what those tasks are doing, that might not be the best choice either. If guaranteed response times are important for you, certainly Cloud Functions can scale in order to give you guaranteed response times for millions of users. But if you have something like a payment application, Cloud Functions might not be the right choice to accept those payments because you want faster response times. And you want to make sure that whatever you're running in terms of serverless is going to be stateless and ephemeral. Because these small containers that are running your applications could disappear and scale to 0 if nobody's using it. And you can't make sure that the next time you call the function that you're calling into the same container. So you really want to make sure that those things are stateless and ephemeral as well. So what about some of the other services? So we do have a lot of other managed services, Cloud PubSub, BigQuery, and even Cloud Machine Learning, which I've talked about. The important thing to remember here is that whenever you're thinking about serverless, you should really think about low ops or no ops, or the type of effort that you're putting into those. And also think about how the payments are structured, because you only really want to pay for what you use. So this page gives you some example use cases around for what use cases you'd want to use with serverless options in Google. One of the ones that I wish I had time to do a demo of is Cloud Dataflow. It's one of my favorite products on Google Cloud Platform. And it's really amazing how we've come so far with ETL. And we've now been able to implement real-time ETL that scales. And again, whether it's one message you're trying to transform or a million messages. So what did we learn? So today we learned what serverless is. We learned what serverless is on Google Cloud. We took a look at X as a service. So platform as a service, functions as a service, back-end as a service. And we took a look at other managed services that Google Cloud provides. So I want you to think about what you might use for your next application or for existing applications, and how you might begin to, rather than lift and shift, think about sort of moving and improving those applications to become more serverless and moving towards a low ops and no ops infrastructure. And with that, we will move to Q&A.
Cool. Thanks so much, Jay. That was a fantastic session. One of the things that came up on the questions, which I think is a good topic to discuss, is as serverless gets more and more buzz around it, more and more questions are asked around, does that not mean more lock-in to a particular vendor? So I tried answering that question, maybe not as eloquently as I could. For me, I think it's to do with a trade-off. You can run things yourself on your own virtual machines or on bare metal, but you've got then a lot more work to do. Over the life cycle of a project, that time and effort into managing all that's going to add up, cost associated with it.
Sure.
Versus running things on serverless, and if you need to then migrate away from that decision, what is the time and cost? How do you think about lock-in in general with serverless?
Yeah, absolutely. That's a very good question. I guess starting with something like cloud functions, migration is actually quite easy, right? Because you are talking about discrete functions, and it makes that easier to move. Again, we're not using our own programming languages. This is written in Node.js. Those functions would be actually quite easy to move. As you take a look at some of the other options that we have, one of the things that Google has tried to do is make sure that we support open source interfaces for our platforms. So with Bigtable, we support HBase. With I had another thought. With Dataflow, my favorite product. With Dataflow, because I really wanted to mention this again, Dataflow, we have an open source version called Apache Beam. Again, so we want you to stay with us because we give you the best performance and we take away all of those operations. So while Apache Beam is a great open source product, one that Google is actively participating in and supporting, you still have to worry about building that underlying infrastructure. So the benefits for Google is that you use our platforms, and the benefit for you is that we can give you that scalability that you need without that upfront investment and the ongoing investment in the operations for those.
Yeah.
So definitely, whenever you're looking at serverless, you should look at the portability of those applications and the interfaces that you're building to those applications.
Very good points. I think triggered some other thoughts in my mind as well. So machine learning. If you're running TensorFlow, again, open source, run it wherever you want. If you need to scale it, machine cloud ML engine, Dataproc, Hadoop jobs. So yeah, I think across our platform, it's a very good point. So we've got some questions that came through today. So run through those.
Sure.
So first up is, what is the best way to write data to a database with Cloud Functions?
Yeah, absolutely.
Any special considerations?
So, well, number one, it is designed for short-lived processes. So if you're doing a lot of interactions, you should think about that. During our beta, I believe the maximum time to live is 90 seconds. That might have changed. So check on that. But essentially, they're designed around short-lived processes. So you want to make sure that those updates stay within that process. The other side of it is, as I said, Node.js allows you to import NPMs. And Node.js is supported by a number of our applications. So you could actually just import those NPMs, do the updates inside of Node.js, and it really becomes just like any other application that you're working with.
Yep, I actually was looking up the answer for that question around how long a function can run. It's now 540 seconds.
Oh, there you go.
Yeah.
Yeah, I know during the alpha they sort of left it open because they were sort of testing it, and then I think when they first did beta they put it in 90, so 540 seconds.
Yep. Yeah, I think the NPM modules that you get with Node, there's so many of them. I've tried to start recently getting my hands dirty with Node. Been very impressed at how easy it is to pull in a few modules and all of a sudden half your work's already done for you, which is great. Okay, so next question is, how do I go about securing my Cloud Functions, and how do I prevent anyone from running them?
Right. So as I said before, number one, it does support any NPM modules, so you can do things like tokens or OAuth in order to control the access that those functions have as well. If you are doing integrations to other part of Google Cloud Platform, you can use service accounts and things as well to make sure that those things don't get exposed. And some of the other types of integrations, which I didn't really go into, but if you're using things from cloud storage, obviously the application that's putting it into cloud storage would protect those functions.
You're moving that to further up or further back in your architecture.
Exactly. And also things like pub sub as well to help, again, control the access to those functions as well, right? So in those specific points, you actually don't have an external endpoint. All of those endpoints are within your project.
Yeah. Well, I guess you'd be doing those things through cloud IAM, identity and access management.
Absolutely. Yeah. So that helps control your access not only to the resources within your project, but also the internal access within the project. And you can use things even like cross-project networking in order to control the access between multiple projects.
Wow. So lots of options.
Definitely.
Okay. Next up, will there be support for other runtimes other than Node.js?
Absolutely. It is in beta right now. As with all of our platforms, we've slowly added additional languages over time. We do expect to support additional languages inside of Cloud Functions. I think with Node.js, I think they made the right decision because functions are so useful to web developers, especially the massive amount of Firebase developers that we have as well.
Cool. During your talk, you mentioned logging and capturing errors and things. I guess my question here would be, how do I actually get alerted to those? Where do I go to find errors if I'm writing the code, there's going to be errors in it? How do I go about finding those?
Sure. So in Firebase, you can actually look at those logs directly from the console. You can also publish those to things like Stackdriver and therefore include it in your overall application. You could also actually, from Stackdriver, then issue alerts, whether those are email alerts or integration with PagerDuty.
Yeah. Okay, great. Now I think as you're doing development, you can be firing command line commands to request kind of what those errors are. So try things, run it,
absolutely,
see all the errors you've created.
Yes.
All right, cool. Okay, and then last up, if you're like me, I like to do as much development sort of locally as I'm trying things and breaking things before pushing it sort of into the cloud and doing sort of bigger deployments. What options are there for me to run Cloud Functions locally?
Yeah, so during the demo, you saw me using the console UI. I think I looked at it for 5 or 6 seconds, making sure that I wasn't forgetting to close a brace or bracket. That's obviously not my IDE of choice, right? No. So right, it's definitely better to do that locally. And we have SDKs available, which actually allows you to do emulation of those functions, so you can actually test and run those functions locally to understand how they're going to behave before you publish those.
Yeah, even though it's Node.js, I guess there's going to be some rails that you want to keep between, so you're not doing things that when you do push it to the cloud that it's not going to work. So.
Absolutely, yeah. You have to have a good understanding of what libraries you're integrating with, what other types of services you're integrating with as well.
Yep, excellent. That was it. I think you did a fantastic job of explaining it. So some pretty good, concise questions there. So thank you very much.
Great, thank you, Richard. So this was our last session of the week. Thank you so much for all of your questions and for all of your participation over the week. I would like to thank our customer engineers and our technical experts that joined us. So we had 12 different sessions over 4 days, and you actually heard from 12 different speakers as well. So I'd like to thank Malcolm, Shaista, Ashish, Hillary, Prakar, Liam, Tim, Gaurav, Win, KJ, and of course Richard.
Thank you.
For all of their help during the week. I get to work with a group of amazing people, and every single time I work with them, I learn something new. So I'd like to thank them. I'd also like to thank the broader crew that helped us put all of this together as well. So thank you again so much for joining. If you would like to know more, number one, you can go back and watch the previous sessions that you've registered for simply by following the link that was sent to you in your emails. Get certified. Right, cloud.google.com/training. Get certified on the platform. Learn about what it means in a deeper and more meaningful way. Participate in some hands-on labs through Quick Labs and Coursera. Contact us if you have any questions about your architectures and how you might be able to make your architectures better inside of Google Cloud Platform. We do have a free tier available for a lot of our services. You can go to cloud.google.com/free to learn about the free tiers. And for G Suite, you can go to gsuite.google.com/training in order to learn more about that. So thank you again, and we will see you at the next Google Cloud on Air.